introduce yourself?
Yes. Hi, everyone. My name is Torben, and I'm from Germany, and I'm studying civil engineering in Germany. And my specialization is water management. Yes, and I'm very, very happy to join you in Malaysia.
So how do we pronounce your name, Torben?
It's Torben.
Torben.
Yes.
Yes, Torben. Okay, so thank you, Torben, for choosing this subject, and we are glad to welcome you in this course. This is water and wastewater treatment. He is from Germany. Where are you now? Are you in Malaysia or in Germany?
I am in Malaysia at UPM.
Oh, you are in Malaysia. Okay, so good to see mobility student come back to UPM again, because I think we have since past 2 years, yeah, we don't have any mobility student, yeah, and now this is the situation is getting better, and we start receiving the mobility student. We do have many actually. Previously, we do have students from Netherlands, from Finland, yeah, from Germany, from Turkey, yeah, as well as from other Scandinavian country. Yeah, so welcome. Okay, we do have Muhammad Belosdi here, Husni Hakim, Mr. Song, Jin Cheng, Ainin Sofia, Najwa Nabila, Farah Izati. Okay, so maybe we can spend 1 to 2 minutes here to introduce yourself to our new friend here, Tobin. Yeah, so maybe we can start with Muhammad Rosdi. Okay, anyone would like to start? Introduce yourself, please.
Let me first, Doctor.
Okay, sure.
Okay, Assalamualaikum. My name is Muhammad bin Rashid. Currently live in Melaka. You can call me Ahmad. Nice to meet everyone of you all. Thank you.
So, Muhammad, where are you now?
Currently in UPM, College Pulau.
All right, thank you. All right, then maybe Husni Hakim.
Hi, good evening, everyone. My name is Muhammad Husni Hakim. So hi, Tobin. Nice to meet you. That's all for me.
Nice to meet you too.
Yes.
Okay, thank you, Husni. Then Ainin Sofia.
Hi, my name is Aini Sofia. You guys can call me Ainin. That's all.
All right, thank you, Ainin. Then Song Jin Cheng. Song, are you ready? Okay, if Song is not ready, then maybe Farah.
Hi, I'm Sun Jing Cheng. Very nice to meet you guys. And this is my 7th semester. I'm 22 years old. I think that's all.
Okay, thank you, Song. Good to see you again. Okay, Farah.
Hello everyone. Good to see you. My name is Nofara Izati. Okay.
Farah.
Here.
Yeah, you are from. Where is your hometown, Farah?
I'm from Kajang, Selangor.
Oh, Kajang Selangor. Right. Thank you, Farah.
Right.
Okay, the next student, you can proceed with to introduce yourself. Maybe we can have Israf Nazmin here.
Hi, Doctor. My name is Isra Nazmin. I'm from Terengganu.
Terengganu. Okay, good to see you again. Next, can we have Jessica?
Hi everyone, and hi doctor.
Hi.
I'm Jessica, and I'm from Selangor.
All right, good to see you again, Jessica. Thank you.
Thank you.
All right, then Firdaus.
Yes, I am. Okay, Assalamualaikum and a very good afternoon to all. My name is Muhammad Firdaus bin Samsudin, or you guys can call me as Os. So right now I am at Kajang, Selangor, to continue my study. Thank you.
Alright, thank you very much, Firdaus. Good to see you. Okay, after Firdaus, maybe Amirul.
Hello guys, and good evening. My name is Muhammad Amirul Hamzah, and you guys can call me Amirul. I'm currently staying at Cheras, Kuala Lumpur, and nice to meet you, Tobin. I hope you have a very good memory here. That's all from me. Thank you.
Alright, thank you, Amirul.
Thank
Good
you.
to see you again. Alright, Nazri. Thank you, Nazri.
Hi, nice to meet you too.
Alright, then Nurin Syuhada.
Hi, can you hear me? Hi, my name is Noreen. Syuhada with Sulaiman. You can call me Noreen. I'm from Johor. And nice to meet you, Tobin.
Alright, Nurin, where are you now?
I'm at college.
Oh, you stay in the college, in residential college. Alright, thank you, Nurin. Maybe we can have Husni Hakim dah. Okay, Muhammad Rusdi. Muhammad bin Rusdi dah Muhammad Rashid dah
Dah, Doktor.
Dah ke? Okay, Ashraf.
Hi, good evening. My name is Muhammad Ashraf bin Asahan. You can call me Ashraf. Nice to meet you.
Okay, nice to meet you again, Ashraf and Amirul. Okay, Muhammad Husni Hakim already. Hakim dah ke?
Belum, Doktor.
Okay, Hakim.
Hi, Doktor. My name is Muhammad Hakim. You can call me Hakim. I'm currently at rumah sewa area the mines. Kat Seri Kembangan.
Where exactly? Oh, Seri Kembangan. Alright. Okay, thank you, Hakim. Nazri already. So we can have Nasrin Syahira. Dah ke? Nasrin dah ke?
Belum, Doktor.
Okay.
Okay, so hello everyone. My name is Nasrin Syahira. You can call me Nasrin. So currently I'm at Serdang, Selangor.
Serdang, Selangor. Alright, thank you. Nazura.
Hi, hello everyone. My name is Nazur Afika. You can call me Nazura. I'm from Kuala Lumpur.
Kuala Lumpur. Alright, thank you, Nazura.
Okay,
Nur Alia Afika.
Assalamualaikum and hi everyone. My name is Alia. I'm from Sungai Petani, Kedah. That's all. Thank you.
So where are you now?
At college right now.
Oh, college. Everyone, most of you are in the residential college, yeah?
Yes.
Alright, good. Hafiza. Hafiza.
Hi, my name is Nahafiza binti Muhammad Isri. I'm from Kedah.
Kedah. Okay, so where are you now, college?
Dekat rumah sewa.
Oh, yeah, okay. Serdang. Okay, thank you, Hafiza. Nur Nabilatul.
Okay, hi everyone. My name is Nur Nabilatul Husna. You can call me Husna. I'm from Klang, Selangor.
Klang, Selangor. So you stay in Klang or you are currently in the residential college?
Currently still in Klang, but we'll go back to uni either this week or next week.
Okay, very soon. Yeah, alright. Thank you. Thank you.
Alright,
Shafika. Shafika.
Hi everyone, my name is Shafika and you can call me Pico. I'm from Gomba and I'm currently at college.
College, okay. Thank you, Shafika. Shazwani.
Hi, my name is Nur Shazwani binti Sani and I'm from Melaka.
You're from Melaka. So currently you are in Serdang or still in Melaka?
In Melaka. This week I will go back.
I see. Alright, thank you. Farah already. Nurul Syuhada dah kan? Nurul Ain.
Assalamualaikum and hi Dr. Wani and everyone. My name is Nurul Ain binti Silong. You can call me Ain. Right now I'm at my hometown, Kemaman, Terengganu.
Oh, still in Kemamal. Okay, good. So when are you coming back?
I don't know, maybe next week.
Oh, next week. So have you started your final year project?
Yes, already Doctor.
Already, okay.
Still in progress. Okay.
In progress, okay, great. Farah, Putri Nur Farah.
Hi, my name is Putri Farah. I'm at Sedang, Selangor and I'm from Shah Alam.
From Shah Alam, okay. Alright, thank you Farah. Aina.
Hello everyone. My name is Siti Aina binti Aziz. I am from Kajang, Selangor.
Kajang, Selangor, okay. Aina, okay. Taufik.
Hi everyone, my name is Taufik bin Azman. I live in Putrajaya and currently I'm staying in College 10.
College 10, alright. Thank you Taufik. Dinesh.
Hi everyone, my name is Dinesh Kanabadi. You guys can call me Dinesh. I'm currently staying at college.
Oh, you are now back in college, Dinesh?
Yes, doctor. Last week I was here.
Alright, thank you very much. I think we have met everyone. Yeah, anyone that I miss? I hope none of you. Currently, in the system we have about 31. Yeah, but the one who joined us today is only 28 now. Yeah, so we are expecting probably another 3 students to join us soon. Alright, so I would like to introduce myself again. Yeah, my name is Shazwani. So most of you call me Dr. Wani. Yeah, I used to teach third year student in the course name environmental engineering. Yeah, so environmental engineering in the third year. Yeah, normally in the third year offered to the third year student comprised of 2 sections. The first section on water, air pollution, noise pollution, land pollution, as well as environmental management. And the second part of the environmental engineering is on water and wastewater treatment. Yeah. So following the topics covered in water and wastewater treatment, this is going to be the advanced version. Yeah, not actually the continuation lah, not really advanced lah, the continuation from water and wastewater treatment, the one that you studied in your third year. So in this course we are going to emphasize more on the substances left in treated water and wastewater. So you have explored before on how to conduct a treatment method, what is the suitable treatment method in a conventional treatment system. But unfortunately, after conventional treatment system, there are substances left. For example, there are high concentration of metals in treated water or wastewater. So this is where the requirement for this course. You are going to look into the technology that is applicable to remove the substances left in treated water and wastewater. Okay, that is the general view. So, okay, let me share the slide. Okay, you can turn off your camera if you would like to do so. No worries. Let me share my slide.
Sorry, doctor. Can I request to record because one of my friend cannot join this class actually?
Yes, you can. Actually, we do have one student who are currently in the United States. I think he did request to record the session. Probably he will come back soon in week 7. Yes, good to know that someone is recording the session. Thank you very much.
I mean, doctor, I want your permission because
so how do I allow you? I don't know. Actually, last semester, one of the student managed to record the session.
I see. I try first, doctor. Later I'll let you know.
Okay, you can
Right,
try.
thank you, doctor. Sorry, doctor.
Okay. Okay, let me share the slide. Yeah. Okay. Yeah, I forgot to introduce myself just now. Yeah, I'm Shazwani. Call me Dr. Wani. So I can be contacted through email as well as you can send message to my phone. My first degree also in civil engineering. By training, I'm a civil engineer. I joined after graduated in Master of Civil Engineering, major in Environmental Engineering. I joined the Ministry of Works as a civil engineer. Then I left Ministry of Work, joined UPM, and I left for study leave in United Kingdom, University of Southampton, UK, for 4 years for my PhD. And I came back with a PhD in biochemical engineering in 2013. So my research background is more on the waste treatment, on waste treatment, on the physical-chemical treatment. But today we are going to emphasize more on water treatment, water as well as wastewater. Okay. All right. So we are going to look into again, the overview, of this course. Before we go further, I would like to share a video. A video on one of the common technology that being used for the advanced treatment, which is known as a membrane bioreactor.
Membrane Bioreactor, MBR. The Membrane Bioreactor, MBR, has a number of advantages over traditional wastewater treatment. In the conventional activated sludge treatment method, sludge is separated into solids and liquid in a settling tank. This is called clarification. The innovative MBR technology combines activated sludge treatment with solid liquid separation by means of microporous membranes, in place of the traditional separation by secondary clarification. The MBR modules can be put in a separated tank after the oxidation tank. This configuration is called standard system. The MBR modules can also be put directly in the oxidation tank. This configuration is called compact system. The MBR process delivers a highly treated effluent suitable for non-potable reuse applications. The MBR system can be rearranged in a variety of configurations. The typical MBR system includes a rotary influence spring and anoxic, anaerobic, and aerobic tanks for biological treatment. The MBR modules and MBR tank, air blowers for the aeration process and for membrane scouring, a pump set for the MBR permeate suction for sludge recirculation, chemical dosing systems.
Okay, so if we go back to this slide, we can see that this is a conventional treatment methods, which is known as conventional activated sludge process, the one that you studied in your third year. So this system, very quick revision, this system comprised of aeration tank, as well as the clarifier. So these are the secondary treatment process where you will employ the return activated sludge. So in the advanced version of this system, they will equip with the membrane bioreactor. Membrane bioreactor can exist as the submerged or a separate as a submerged like this, or as a separate system where it is not being it is not submerged in the tank, inside the tank. So this is one of the innovation that have been explored before, so that having the membrane inside the tank will improve the quality as well, the quality of the treated wastewater, as well as to reduce the suspended solid. You know, one of the challenge when we employ the conventional treatment method is to deal with the sludge treatment. Dealing with the sludge treatment is not easy. We are not in the stage to spend lots of money for the treatment of the sludge. For information, as I mentioned last year, the wastewater operator need to spend more money for the sludge treatment as compared to the wastewater treatment itself. So that you can see, we are looking for a technology that can reduce the sludge production. So this is one of the technology that can be employed so that the suspended solid, this total solid that being produced is the total solid that produced can be reduced, can be reduced so that we can reduce the total operational cost for the wastewater treatment as well as water treatment, because both water and wastewater treatment do produce sludge. Okay, let's see. Let's see what is actually the membrane system.
Conventional activated sludge processes. Flat sheet Mbr membrane modules are fully submerged into the mixed liquor inside the tank for direct outside to inside filtration. The modules are made of robust reinforced flat sheet membrane with a nominal pore size of 0.04 micrometer. The membrane separates solids and microbes from the activated sludge. The module aeration system generates an upward water flow and air flux to prevent membrane fouling. This allows extreme efficiency up to 99% in suspended solids removal, delivering highly treated.
So these are the cross section. The cross section. The one in white in color is the membrane sheet. So that when we employ a membrane, the membrane sheet will act like a filter, but in a very small pores, so that it can remove the not only the suspended solid but also to remove the dissolved solid. So the one that we filtered out is known as the permeate. Permeate is the filtered water, is the treated water, while the one that cannot pass through the membrane sheet is known as retentate or the concentrate. So later we shall have about 2 weeks of lectures to study about only the membrane technology, because the topic are pretty long as compared to other topic, but not only on membrane. We shall focus on the adsorption technology, on the desalination technology, because these are the advanced version. The advanced version, what is the appropriate technology. By the end of this course, you should be able to give recommendation on what is the appropriate technology to be used in case that we have certain types of the pollutant. So because at tertiary level, at advanced level, different technology are being developed based on the specific pollutant. Okay.
Water suitable for reuse. Mbr technology offers a number of key advantages over conventional wastewater treatment plants. By eliminating the need for secondary clarifiers and tertiary treatment, a smaller footprint is possible. Higher strength effluents can also be treated. Mbr membrane technology produces an improved water quality in the treated water versus conventional activated sludge treatment systems. This not only helps ensure that specific effluent discharge limits are met, but also gives the customer the potential to reuse the water. In addition to standard installations, Mbr systems are available in a wide range of configurations designed to meet your specific needs, such as containerized solutions for remote sites, or retrofit systems to enhance the performance of existing treatment plants. Membrane bioreactor systems offer the latest technological solution to meet your wastewater and water reuse needs.
Okay. Another one is known as moving jet bioreactor. We have studied this before during the 3rd year.
Mid
Okay. There are three different systems: MBR, MBBR, and FBR. Yeah? Very good one.
The comparison of the three systems showed different advantages and disadvantages for industrial wastewater applications. Effluent water quality. MBRs show in general a slightly better BOD removal than MBBRs or FBBRs. Very fine membranes can even hold back germs so that the water effluent quality is in general better. Resistance to influent peaks and grease leaks. MBRs are very sensitive to changing influent values. Grease leaks can cause clogging of the fine membranes so that they must be cleaned or replaced. MBBRs are less sensitive as MBRs, although the risk of fill media clogging is high in case of interrupted mixing and grease leaks. Instead, FBRs are very robust and show a very good handling of either changing influent values, grease leaks, and interrupted oxygen supply. Difficulty level of operation. MBRs require monitoring of the activated sludge process as well as backwashing of the membranes in certain intervals. Therefore, their operation can be challenging and higher qualifications are necessary. MBBRs and FBRs are more forgiving, and especially FBRs are easy to operate. Required space. The higher MLSS level of MBRs allow more BOD removal per water volume. Therefore, their required space is lower compared to MBBRs and FBBRs. Energy consumption. Due to higher MLSS, permanent backwashing of the membrane and fouling prevention, MBRs need a high air volume, thus have a high energy demand and cost. FBRs require less energy as MBBRs because the air supply of the biofilm is installed directly underneath the fill media, which results in a better oxygen intake. Overall cost. The installation costs for all three systems are about the same. However, over time, MBRs are more expensive than MBBRs and FBBRs because of higher operational and maintenance costs. All in all, MBRs are a good fit for applications that require a high-quality water effluent. Instead, MBBRs and especially FBBRs are a good solution for pre-treatment of high BOD levels. Their resistance and forgiving design make them suitable for various industrial wastewater applications. Additionally, the easy operation and maintenance guarantee a long lifetime production solution for low cost in the long term. In case you wish further information or need support with the design of your project, please contact us. Thanks for watching. And if you like our 3-minute leaks can cause clog.
Yeah, so this is one of the best video, yeah, where it compare between the three innovation, yeah, in the wastewater treatment technologies. Yeah. The first one is membrane bioreactor. The second one is moving bed bioreactor, and the third one is fixed bed bioreactor. So what are the major difference? Yeah? First, we look into the configuration. In terms of configuration and the material use, yeah, membrane bioreactor, of course, they employ membrane lah, yeah, membrane technology. The second one is moving bed bioreactor. Moving bed bioreactor, it doesn't employ membrane, yeah, it's employ a filter system where at the same time there will be air which is supplied into the system. Yeah, so that will allow the microorganism to attach within the filter media, but the media is moving. Yeah, that's why it's known as moving bed bioreactor. Yeah, the media keep moving. So and the last one is fixed bed bioreactor. Fixed bed bioreactor is a system where the media is not moving. Yeah, we culture the media, we culture the microbes within the media, but the media is fixed to the certain place. Yeah, so as you can see, yeah, for the membrane bioreactor, it took hours, yeah, to cause clogging. For moving back bioreactor, less than 1 day of that it will cause clogging. Yeah, for the fixed bed bioreactor, it will take a few days. Yeah. Okay, in terms of quality, yeah, moving back by membrane bioreactor will produce excellent quality of water as compared to MBBR and FBBR. In terms of resistance, yeah, when the maintenance required, the best one is fixed bed bioreactor. And membrane until now, the membrane technology is one of the technology that can produce a very good quality of water as well as treated wastewater. Nevertheless, the major disadvantages, yeah, of employing this system is require frequent maintenance, is require chemical cleaning, is require high very trained workers, yeah, to conduct the maintenance work. Yeah, that's why in terms of resistance here is full. Yeah, in terms of difficulty of operation is very high. Yeah, it's require very highly trained person. Yeah, then only the maintenance work can be conducted. In fact, at certain period we have to use a chemical cleaning. Yeah, then only we can remove this the pollutant or the contaminants that stick within the pore surface of the membrane. Yeah, because as I mentioned to you just now, membrane is work like a filter. Jadi macam penapis tu, it's like a filter. So after certain um, after few round, yeah, so it will, the contaminants will start to stick within the surface of the membrane. Yeah, so that's where it's require maintenance. Yeah, as compared to MBBR and FBBR, they are very easy. They are the easiest one. Yeah, the easiest one in terms of operation and resistance. Okay, so the next one, yeah, in terms of space required, yeah, you can see in terms of space required, definitely membrane is the lowest one. But compared to the three, comparing between three of the technology that available here, the membrane required the lowest and lowest space. Yeah. And but still, yeah, because they are advanced technology, conventional activated sludge system still the technology that require very the highest space lah, the highest space required if we employ the conventional methods. Yeah. Okay. So in terms of energy demand, yeah, if we can compare in terms of energy consumption, yeah, membrane require high energy consumption. You know why? Because when we employ membrane, we have to use a pressure pump. Otherwise, the raw water or raw wastewater cannot pass through. Yeah, cannot pass through the membrane media because the pore of the membrane is extremely small. That's why we have to use the pressure pump so that it can force the pump, it can force the raw water or untreated water or wastewater to pass through the membrane. Yeah. Comparing between MBBR and FBBR, membrane is the highest one, yeah, in terms of energy consumption. So these are the overview. We are going to compare in details. Yeah. So by the end of this course, yeah, you should be able to give the right recommendation, yeah, based on the existing problem, based on the constituent, yeah, of the treated of the raw water and wastewater to be treated. Okay, all right. Okay, all right. In terms of assessment, okay, in terms of assessment, in this subject, we are going to have final exam 40%, yeah, project 15%, only one project, only one project, which is 15%. Assignment 1, 3%. Assignment 2, 3%. Assignment 3, 2%. So assignment 1 and assignment 2 will be conducted before the semester break. While assignment 3 after the semester break. Your test 1 will be conducted in week 7 or week 6, and your test 2 will be conducted in week 11 or week 12. Okay. So today I'm going to pass to you your first assignment. Okay, already have your first assignment. Okay, so general overview about reservoir management system. We are looking into the quality. Why we put some concern. Why we have to care about the reservoir management, because we hope that we can preserve the quality of water, not only the quality but also the quantity. So these are the factors that can cause that can affect the quality of water, which includes the major one is human activities, agricultural runoff, livestock, industrial discharge. So even for your information, in this country we don't have any specific treatment methods that can be employed by the farmers for the treatment of livestock wastewater. Most of our livestock waste and wastewater still go through direct into the river, direct into the sea without any treatment. So that this is our challenge. Our challenge, your challenge as a future civil engineer, future water engineer, as well as environmental engineer, to look into this issue, so that proper management is required to reduce the impact to the environment, so that we can preserve the quality of the water. Apart from human activities, natural occurrence also one of the factor which can contribute to which can affect the water qualities. As many years ago, I did collect groundwater sample from Negeri Sembilan. Unfortunately, the groundwater sample contain high concentration of ferrum. There is no human activities within 1 kilometer radius, which indicates that the ferrum which exists in that particular groundwater is caused by the natural or geological reaction. Ferrum exists in groundwater is perfectly fine, but when you extract the groundwater and it will react with the oxygen, it will produce ferrous oxide. Ferrous oxide at lowest concentration is fine, safe to drink, but at higher concentration, it can cause problem. But the most the one that really attract our attention is when ferrum meet oxygen, it will produce ferrous oxide, so that the color will turns into orange. So it's not happy to drink. We consider that as impotable water, because if we can define potable water, is water which is safe to drink. It should be suitable to be used for domestic purposes. It should be colorless, it should be tasteless, and it should be odorless. So that's how we define potable water. Okay, eutrophication is another issue, which has been discussing about nitrogen. We have been discussing before. We have discussed about nitrogen cycle. The factors that can contribute to the nitrogen, the runoff from the agricultural activities, the septic tank, from the residential area. For your information, we know there are three major elements that can cause eutrophication, that can enhance the development of eutrophication. The first one is nitrogen, the second one is phosphorus, the third one is potassium. But this will only happen at the right ratio. Yeah, phosphorus is the limiting factor. Is the major element which can cause eutrophication, the algal bloom. Yeah, the algal bloom. But at the right ratio to nitrogen, then only it can produce the eutrophication or algal bloom situation. Okay, so why do we need to put concern on eutrophication? Yeah, eutrophication can cause the situation of algal bloom, and by the end of the day, it will be competition, yeah, with the aquatic life in terms of the light, in terms of the oxygen available in water bodies. Yeah, that's why the runoff, especially from agriculture, is the toughest one, because it contains high potassium, it contains high nitrogen and phosphorus, yeah, from the fertilizer. Okay, so apart from that, urban and industrial source, the management of the industrial wastewater, the management of slaughterhouse wastewater, yeah. What is the current practice of the slaughterhouse center in this country? Yeah, many of them, they don't have any specific treatment method. They just allow the untreated slaughterhouse wastewater to flow into the drain and direct into the river. Yeah, same goes to other farms. Yeah, not only slaughterhouse, not only chicken slaughterhouse, but if we are to compare between chicken and cow, definitely the cattle slaughterhouse will produce more wastewater. Yeah, so currently they do have, some of them, they do have the treatment methods. Yeah, unfortunately, the treatment method is only works during when they are inspection. Yeah, when they are inspection from the officer. So this is definitely not a good practice. Yeah. Okay, the government also is looking forward, yeah, to allow the food and beverage wastewater to combine with the domestic wastewater, so that we can improve the loading rate, yeah, of the domestic wastewater treatment. But they are not yet into the final decision. Yeah, they are looking forward, to introduce this. Okay. Okay, next one is regarding on reservoir management. Yeah, definitely we have to provide buffer area, yeah, to avoid the cutting of trees and burning process, so that we can ensure the water security and safety of the reservoir, as well as the source of water. And we have to ensure watershed management, yeah, avoid the fertilization, industrial discharge, so that we can preserve in terms of the quality. There are few factors that can affect the quality of our water storage lah, not only in terms of the industrial runoff, industrial untreated industrial wastewater, but we are also dealing with the sediment issue. Sediment issue. Most of the issue regarding on the flood, especially in the state of Selangor and Kuala Lumpur, we do actually have sufficient pond. We do actually have sufficient pond, so that we can avoid the flooding area. But due to the inefficient drainage system, due to clogging, this has caused a lot of problem, and the community is the one who has to pay back. Who has to see the damage of the houses due to flood. Okay, so this is water intake structure. Okay, back to the story of water treatment plant. In water treatment plant, we do have a few sections. The first one is water intake structure. This is available next to the river. Okay, because in this country, normally we shall extract water from the river. So water intake structure is normally available next to the river. There are 4 types of water intake structure. The first one on my left, top left, is the sunken pond. No structure required. The next one is with diversion pond. The third one is with without the pond but with the diversion. They are diversion, and the last one there is no diversion, only barrage pond. Okay, so this is the don'ts. When we decide the exact location of the intake point, we have to avoid the inside of the curve. Why we have to avoid inside of the curve? Because this will be the place where the silt, sand and gravel will accumulate. So it's not a good choice, it's not a good decision to construct a water intake point in the inside of the curve. So this is, you imagine this is the river. So this is the going to be the water intake point. So these are the recommended point at the right location, so where you can construct water intake point. Okay, next one is off river storage. Okay, off river storage is the technology or the very good innovation, so that we can preserve the quality of water as well as the quantity of water. Okay, let's spend 1 minute to watch this video. I believe that you have watched this before. A very short video on off river storage. The importance, there are 3 importance. There are 3 significance of having the off river storage. So the first one is to preserve in terms of the volume of the water, in terms of the quantity of the water. Okay, the next one is to improve the quality of the water, because having the off river storage, there will be a movement of water from one point to the other point. Okay. Alright, these are known as off-river storage. There are 3 ponds next to the river. This is the first pond where water from the river will flow into the ponds. From one pond to the other pond, there will be a channel. So this is where they will put. A cube with the silt trap. To reduce the sediment. So definitely in terms of the quality, the first pond, the second pond is better in terms of quality, because it will take some time for the sediment to settle or to be trapped within the sediment trap. So this is what I mean by the advantages of having the off river storage. We can store lots of water, especially during drought season, especially during for example during the pollution, so that let's say there are pollution at certain point of the river, so that we have reserve water that has been reserved at least for 3 ponds. So the next pond, after this pond is the final pond, which is normally known as pond C. So pond C is the one who will supply the untreated water to water treatment plant. So there are 3 major advantages of having the off river storage. The first one is to preserve in terms of the volume, to preserve in terms of the quality, to improve the quality of the untreated water. And the third one, it can be used as the flood mitigation. Flood mitigation, because the off river storage is just like a pond. Three ponds next to the river. The overview of water treatment system. Today we are not yet into the advanced version, because I think that it's better for us to have the overview, and then we can to revise, what is the water treatment system. These are the water intake point. Water intake point just now. This one located in Dengkil, Selangor. And these are the bar screen. Bar screen is the first treatment method, the first treatment system in water treatment plant. The function of the bar screen is to remove the large particle, the debris. This is extremely important, the first barrier. The first barrier of water treatment. We have to remove the debris because we would like to avoid the mechanical abrasion to the devices involved in water treatment process. Okay. This is the pump station. Okay, these are the overview of the treatment process which is available, which has to be conducted in a conventional treatment system. In a conventional treatment system, there are coagulation and flocculation, there are chemical addition, there are sedimentation process, there will be filtration process and disinfection process. Okay, what will happen after these conventional treatment methods? There are high concentration of metals, for example, in treated water. So this is where that the tertiary treatment or advanced treatment method are required. So the one that I currently share with you are the conventional treatment process, the most common process that will occur in conventional treatment plant. Addition of alum, very quick revision, addition of alum will occur here, so it will form flocks. Flocks will settle to the bottom part. So the role of this stage is to remove the suspended solid. Next is the lime addition. Now, lime addition is the process for adjusting or to soften the water. Why do we need to add lime? Because lime can soften the water. Why do we care about soften or to harden the water? Water in this country, the concentration of magnesium and calcium is high. Why is it so significant? Magnesium and calcium can cause hardness in water. Why hardness is important? We need to reduce the hardness in water because the higher the hardness in water, it can cause higher soap consumption. It will take hours to produce bubble if the hardness is too high. That's why lime are the most common methods are being used to be added into the raw water after coagulation process. We add lime so that the antagonistic effect between the lime addition as well as the magnesium and calcium can reduce the hardness of water. So after chemical addition, there will be sedimentation process. So these are the conventional treatment system where we will allow some time for the suspended solid to settle to the bottom part of the tank. So in this tank, we have to consider some time for the hydraulics retention time. What hydraulics retention time? Hydraulics retention time is the time that we provide to water to stay within the tank without any action. So water will stay calm inside the tank without any action. That is known as hydraulics retention time. After sedimentation process, there will be filtration process. Okay, the first layer, bottom layer is the gravel. The next layer will be the sand. The third layer will be the activated carbon. Nowadays, most of our water treatment plant, it will be a tube with the activated carbon because having sand and gravel is not sufficient to remove the dissolved material, the dissolved substance, especially some of the dissolved solid like minerals. So it's required activated carbon to absorb all those minerals, ions. After filtration process, in this course, we shall cover in detail on a deep filtration process, and later I will share with you how to design. I will share with you on how to design the activated carbon in the column filtration. Okay, after filtration process will be this disinfection process. Disinfection process.
Thank you, Doctor.
Do you have any question?
No.
Okay. All right. Where? Okay, here. Okay. Disinfection process is the common process in this country. Normally we use chlorine, chlorine addition to kills the germ, but in this course we shall look into other methods that can be used to kills the germ, not only by chlorine addition. We can also use ozone treatment. We can also use UV treatment to kills the germ after filtration process. Okay, the issue that we have to address in this course is what happened after disinfection process there are still substances left where it's required treatment. So these are the stage, these are the technology that we shall explore together, and by the end of this course you should be able to advise people. You should be able to give some recommendation what is the appropriate technology to be used so that we can effectively treat the water. Okay, so these are the real photos in water treatment process during coagulation, in coagulation tank. So by definition, coagulation process is the process of alum addition. Coagulant addition. Flocculation process can be defined as the rapid mixing process, because without rapid mixing process, there will be difficulties for the alum which has been added earlier, the coagulant which has been added earlier to attract the suspended solid to forms the flocks. So that's why we have to promote the formation of the flocks through mixing process. Okay, example 1. This is not really an example, a very short and simple example for the water treatment plant, which treat about 36,000 meter cube per day. Design the volume of flash mixing tank for flocculation where the detention times is 40 seconds. Okay, this example require very simple formula where we know that flow rate is equal to volume over time. So in this case, you are given the flow rate, you are also given the time, so definitely you are looking for the volume. You solve for this equation, you will get the volume about 17 meter cube. So these are the proposed size about the length, the width, and the depth. Okay. Example number 2, determine the basin dimension of uniform depth axial flow flocculation basin to treat the same flow rate of water, but the detention time now is become 50 minutes and the basin width is 25 meters. It's also consisting of 5 equal width units separated by a concrete wall. Okay, knowing the first you need to find the volume based on the given detention time. And detention time is now given as 50 minutes, so this is only the unit conversion. So you will get the volume. Knowing the volume, and you are also being given the width of the basin, so that you know the since area is equal to volume divided by width, so you will get the area. So the left area is the length times the depth. So now you need to propose for the depth is equal to 5 meters. This is a reasonable depth for a tank. So length is equal to 50.5 divided by 5. This is assumed to be assumed, so that the length is equal to 10.1 meters. So therefore the basin dimension is length times width times depth is equal to 10.1 times 5 times times 5. Yeah, very simple. Okay, this is the revision on how to estimate the population. Yeah, estimating the population are extremely important, yeah, for the designing of water and wastewater treatment. Wrong population estimation meaning to say that your design, your water treatment and wastewater treatment plant will be under designed or over designed. Yeah, okay. It's always like that. Even though even the treatment plant in Putrajaya, it's been designed for 100,000 population, but it's been 10 years since the operation. It's only 40,000 incoming flow. Yeah. Okay, so it's always under design. Yeah, so population estimation can be calculated using few methods. The one that I currently share with you is known as arithmetic methods. Yeah, arithmetic methods. Yeah, so for example, in 2015, you have, but using the arithmetic methods, you need to know at least two previous year's population, because you need to know the coefficient. The constant here is important because you need to know what is the rate of the increment. Yeah, for example, in 2015, the numbers of population is 20,000. So that in year 2020, the numbers of population has increased to 23,000. Yeah, so first you need to calculate the constant, the rate of the increment per year. 23,000 minus 20,000 divided by 5. 5 is the difference between these 2 years, and you will get the constant, the rate of the increment about 600% per year. Okay, so that to calculate the population in 2045 and 2020, you use the latest population, the information that you have, the latest information that you have, plus CT. So N 2020 is 23,000, C is 6,600, and the difference in terms of years, yeah, this is 25 years. Yeah, so that you know that the population for the city of Serdang in 2045 is equal to 38,000 person. Yeah, so this is the first method. The second method based on the numbers of residential. These are the most common methods that being used by the water operator to estimate the population before they can decide about the size of the treatment plant. Yeah? So normally they will calculate, they will check in terms of the development. Yeah, what will be the estimated number of houses after certain period. For example, if they are designing a water treatment plant for 10 years, then they need to know what will be based on the plan in terms of development plan, what will be the numbers of houses. Knowing the number of houses, they just they can estimate the number of person, the numbers of population, because it is assumed that one houses will occupy about 5%. So in this case, if we use these methods, we will get about 35,000 population in 2045. Yeah, because 7,000 houses times 5. Okay, for both methods, whether we use the methods of the numbers of population or methods of numbers of residential, water demand estimation is equal to population times 2 to 5 liter per capita per day. Yeah, so these are the how to estimate the water demand. So these are the fixed numbers to be used, yeah, at this moment. Yeah, at least at this moment, because because these numbers tell us that the volume of water that consumed per person per day. Yeah, C stand for capita. Yeah. Okay, these are the water demand for various premises. This is based on the Malaysia Standard 1228. Yeah, so they developed this based on the British standard. Yeah, but now this I believe that the structural people they use Euro code. Yeah. Okay, so for residential is assumed that 5 occupants per day per unit. For commercial area is based on the area. Yeah, so 6,675 liter per 100 square meters. Okay, this is 675 liters. Yeah. For this school, for full residential will be 2 to 5. Yeah, for those who stay in the asrama. For half day school is about 45 liters per student. Okay, so for hospital is about 900 per bed. Very high, very high consumption of water in the hospital. Hotels about 900 per room. Factory about 68 per staff. Yeah, and the bus terminal is about 900 per bus per bed. So this is how to estimate the water demand. That's why they need to know the development, the plan for the development, because because knowing the plan for the development will help the water operator to estimate the volume of the treated water, the volume of the water required, to be supplied to the consumer, so that they can build a suitable size for the water treatment plant. Okay, this is the story about unaccounted water. What is unaccounted water? Unaccounted water is also known as non-revenue water. How do they know they have the issue of non-revenue water? Okay, for the water operator, when they release the treated water, they know this is the volume. Yeah, but when they check with the billing system, the volume of the water used by the registered consumer, they are not tally with the water released from the water treatment plant. The billing is not tally with the water release from water treatment plant. So they should be missing somewhere. Yeah, this is known as non-revenue water. This is not only the problem in this country. It's all over the world. The issue is happened all over the world. But recently, I do have one master by coursework student. He is actually a staff at IS Selangor. He did a short study regarding on this issue, and he found that number 2 and number 3 are the major factors contribute to the non-revenue water, which is the second one is the leaks in the distribution system. The third one is the accidental pipes break. Actually, I was thinking number 4 is the major contributors, which is the illegal tapping or water stealing. Unfortunately, based on his finding, number 2 and number 3 are the major factors contribute to non-revenue water. Actually, we do have 4 major factors. But number 2 and number 3 are the major contributors to the unaccounted water. Okay, all right. Here, I would like to open for the discussion. I have 6 topics here, and maybe we can spend about 15 minutes to discuss this, only to address the point. Yeah. How many of you? Currently, we have 31 students. Yeah. Oh, just to the right numbers. We have 31 students and we have 6 topics here. 30 divided by 6, 5. Okay. Can we have 5 or 6 students per group? Yeah. Can we have 5 or 6 students per group? Yeah. You don't have to worry to develop a group. This is going to be a very short discussion. Okay, you are going to have another platform to discuss about this topic. Ainin, Sophia, Hanis, Israf, Jessica, and Firdaus, and also Amirul. You will be in one group. The first group with the first topic on water stealing issue. Repeat, Ainin, Sophia, Hanis, Israf, Jessica, and Firdaus, and also Amirul, the first group. The second group, Ashraf, Muhammad Roshdi, Hakim, Husni Hakim, and also Nazri. 1, 2, Okay, please accept my apology. Okay, for the interruption just now. Okay, so just now we are in the second group. Yeah. So Muhammad Ashraf, Muhammad bin Roshdi, Muhammad bin Roshidi, Muhammad Hakim, Husni Hakim, and Nazri, and also Nasrin will be in one group, and group number 2. Nazura, Aina, Alia, Hafizah, Nabilatul, and also Najwa, group number 3. Shafika, Shazwani, Farah, Nurin Shuhada, and Nurul Ain, and Putri Nur Farah will be group number 4. Siti Aina, Song, Jin Cheng, Taufik, Dinesh, and Tauban will be the final group. How many groups we have now? 5 groups. Huh? We're supposed to have, we have 6 topics. We have 30 divided by, oh, we are supposed to have only 5 per group. Okay, only 5 per group we have, because we have 6 topics. Okay, again, Ainin, Sophia, Hanis, Israf, Jessica, and Firdaus will be in one group. Amirul, Ashraf, Muhammad, Hakim, Husni Hakim, the second group. Group number 3 will be Nazri, Shahira, Nazura, Aina, Alia. Group number 4, Hafizah, Nabilatul, Najwa, Shafika, and Shazwani. Group number 5, Farah, Nurin Shuhada, Nurul Ain, Farah, Putri Farah, and Aina. And group number 6, group number 6 will be Song, Taufik, Dinesh, and Tauban. Yeah. Alright. So these are the topics that I would like you to spend maybe 15 minutes only, because you have to prepare only one slide. Yeah. To highlight the point regarding on this issue. Yeah. In the meantime, yeah. So that I'm going to share. I hope that you can. I will share this slide for this 15 minutes. So now is about 3:14. Yeah. So you will now, what you are going to do is to create another platform. Yeah. So that you can discuss about this topic. And you shall come back at 3:30 with only one slide. Yeah, you don't have to prepare 3 to 4 slides. Only one slide highlighting the point about this issue. Yeah. All right. So we start now, and at 3:30 come back to share the output. Yeah, only one slide. Okay, you can start now, everyone. You create a platform, another platform. Just allow everyone from your group to join the online discussion. Thank you. Any question?
No.
All right, great. Okay. Thank you very much, everyone. I'll see you in 15 minutes.